So if you're following along with me, we are on page, where did I have you all read? 482, right? I handed you the book that had my page marked in it. Page 482, where we're dealing with molarity, right? So, if you had to define what molarity is, can somebody with a raised hand give me what is molarity? Yes, ma'am.
The number of
moles of solutes divided by what? Not moles. Liters of, not solvent, right? Remember that was one of the big points that our Pogil made. Not of solvent, but of solution. Which, of course, is that combination of the two, right? And so it's a way that we measure concentration. All right, so let's look at example problem number 2 in your textbook. You are given a 100.5 milliliter intravenous solution, an IV, right? The stuff they put in to your body in the hospital, right, when you're sick, that contains 5.10 grams of sucrose, which, sorry, not sucrose, glucose, which is C6H12O6. And they want to know what is the molarity of this solution. Because remember, molarity is that big M, the big kind of script italic M. Okay. So there's two things we have to figure out, right? How many moles of glucose do I have, because that's our solute, and how many liters of solution do I have? We cool? Do they give me moles of solute? No. Do they give us a solute? Glucose, right? Glucose, yeah. But how do they give us that? In what units? In grams, which is mass, right? It's not moles. So how can I go from mass to moles? What conversion can I use? I can use molar mass, right? So the molar mass of C6H12O6, you could look up on the periodic table, add 6 carbons, 12 hydrogens, 6 oxygens, right? But your textbook very nicely in this example gave it to you. They said that the molar mass is 180.16 grams per mole. So, we'll use that number. Are you comfortable with that? So, let's try it. 5.10 grams, and I'm changing it from grams to moles. So, will that 180 go on the top or on the bottom? How do you know? Here, that goes there, right? So 180.16 grams in how many moles? 1 mole. So 5.10 divided by 180, and I get 0.0283 moles. Now, why did I round it that way? Because it's a long number. If you actually pop it in your calculator, it gives this big long number. Because of my significant figures, right? That's 3 significant figures. Excellent. Okay? And these first 2 zeros are just telling me where the decimal place is, so they are not significant. Am I done? No. Okay. Because I've got moles of solute, right? But I need to know liters of solution. What did the problem tell me? 100.5. But is that liters? What is it? Milliliters. Okay, so I have my 100.5 milliliters. How do I change it from milliliters into liters? Divide by? Not 100,000. 1,000 milliliters in 1 liter. And again, I'm showing you using the skeleton because that tells you whether you multiply or divide, right? Because again, my milliliters are here, they have to go down to cancel out. So 100.5 divided by 1,000 is going to be 0.1005 milliliters. Oops, not milliliters, liters. Are you with me, friends? I had to do those two pieces because in order to get molarity, it has to be moles over liters. It doesn't work with any other units. Make sense? And now what do I do with these numbers? I simply divide them, right? So I'm going to take my 0.0283 moles. I'm going to divide it by the number of liters, which is 0.1005. And again, do my rounding piece, and I get, anybody? 0.283. Nope. Sorry, my apologies. 0.2, no zero there. 282. And the units would be moles over liters, right? But I can simplify that to say 0.282 big M, right? That molarity M. Does that make sense? And again, I say this because you will do these in our summative assessment. Okay, you have to be comfortable with doing these molarity calculations. Moles over liters. Comprende? Any questions there? Walk us through the steps one more time. We're trying to get moles over liters. Because they gave us grams and milliliters, I had to change from grams to moles using molar mass. I had to change from milliliters to liters using my conversion, 1,000 milliliters and 1 liter. And then I simply took those two numbers and divided them to get my 0.282 molar. So if I were to say I need a 0.282 molar solution of glucose, this is how you would make that. With 100.5 milliliters of solution and 5.10 grams of glucose. Make sense? Okay, pretty straightforward. I'd love for you to do during this period, and I'm going to give you the whole rest of the time, so you've got 26 minutes to work on page 483. You are doing numbers 16 through 19. It's due tomorrow, but I bet you can finish it today. Go for it.